Thank you so much for having me. I'm excited to be here. First Socrata Summit. My name is Jonathan Schwabish. I'm going to talk to you today. First, I'm excited to be standing in front of an IMAX screen. I was going to put tromping elephants or jumping whales, but I thought I would stick to data visualization, which is what I'm really excited to talk to you about today. Because how you visualize your data and improving the way you visualize that data can improve the way you communicate with your audience. And I'm going to talk to you about a few ways that you can do a better job, a more effective job, a more strategic job of communicating information to your audience. Because for many of us in this room, we have followed a fairly typical equation to present information to an audience, and that has been to take a graph and embed it in a report and surround it by a bunch of text. But over the last few years, we've seen some very exciting developments in the areas of data management tools, open source software, open source programming languages, data visualization, presentation techniques, all of which are enabling us to visually communicate our work in vastly different ways. And data visualization at its core is about communication. And so I want to talk to you about ways in which you can do a better job of visualizing your data to emphasize your results and can do a better job communicating to your audience. But before I do that, let me tell you a little bit about myself. I was born in the blizzard of '77 in Buffalo, New York, not in that car, but in the blizzard. So if you're from Virginia or DC, we had sort of a bad winter. It didn't really faze me. I'm used to those sorts of winters. I stayed in the cold weather for my education. I did an undergraduate in economics at Wisconsin and a PhD in economics at Syracuse University. I have written a book. I note here that it's my best-selling book. The pronoun is very important. It is not a best-selling book. It is my best-selling book. It's currently ranked about 11 millionth on Amazon, which means I bought a copy and my mom bought a copy, and that's pretty much it. I moved to DC about 10 years ago. I started work at the Congressional Budget Office. I was hired to help work on their long-term microsimulation model. So I started working, for those of you who are Fortran programmers, we coded in Fortran. I started working in Social Security policy, retirement policy, inequality, and then I branched out to do research on immigration and food stamps and disability insurance. And then a few years ago, I became interested in data visualization and presentation techniques. And then as was mentioned a few months ago, I moved over to the Urban Institute, where I now split my time between my economic research agenda and working on data visualizations and presentation techniques. And what's interesting about these two agencies is when I was at CBO, our audience was members of Congress and their staffs. That's who we were targeting. So creating interactive visualizations was not very high on our list because we did not really think that Nancy Pelosi or John Boehner were going to sit down with some sort of interactive display and play around with it. Now at the Urban Institute, we're of course interested in communicating with policymakers, but also have a broader audience of the public, media, practitioners, other NGOs. So we have a sort of more difficult task ahead of us because we have to think about how the content meets the needs of each one of those audiences. So people ask me, why did I pivot from being a sort of standard economist to doing data visualization? And there are really two reasons. The first reason is that I became sort of disillusioned or not so impressed with creating 30, 60, 90, 200-page reports that sort of just went out there and disappeared into the ether. No one seemed to pay attention to it. And I feel that data visualization is one of those ways that we can get people to pay attention to our work, pay attention to our analysis. The second reason is that I moved from Washington, D.C. to Northern Virginia. And when we moved to Northern Virginia, we decided we were going to redo part of the kitchen. And so we interviewed a bunch of contractors, and one contractor came out and he said, you know, I don't like your kitchen floor, because when I look at that kitchen floor, my eye is drawn to those dark, heavy grout lines. When instead, what I should be looking at is the tile, the design, the color, the texture of the tile. That's what's supposed to be beautiful. That's what I should be paying attention to. So we redid part of the kitchen, and this is the floor we ended up with. You can call my wife if you don't like the tile, but I think you could agree when you look at this floor, this picture, your eye is not drawn to the grout lines. It is instead drawn to the texture and the design and the style of the tile itself. And I tell you this story because I use it as a metaphor for what we should be doing when we visualize our data. That we want people to be looking at, what's beautiful in our work is the data. That's what's important. And all the stuff that distracts or distorts from that effort, dark and heavy grout lines, tick marks, data markers, data labels, text and legends that's completely disconnected from the graph, all of that distracts from our effort to effectively communicate information to our audience. And what we want to do when we create visualizations is get our audience to say, wow. And whether it be they lean forward and they interact with the display or they explore the data, or whether it be they lean back and they're stunned by the visualization, by its form, its shape, its color, maybe the technology behind it, our quest is to determine which type of wow we want to elicit from our audience. And to sort of try to help you create a guideline or a framework to create effective visualizations, I want to talk about the purpose of data visualization. And when I think about the purpose of creating visualizations, I think in axes or in spectrums. And the first axis is one that runs from analytics to presentation. On the analytics side are visualizations that we create to better understand our data, or our models, or our methodologies, or our projections. On the presentation side are visualizations that we use to communicate information to our audience, to our customer, to our user. Now, it may be the case that the scatter plot you use on the analytics side is the same scatter plot you'll use on the presentation side. But there are fundamental differences between the two because they have fundamentally different purposes. On this side, you are learning about your data. On this side, you are educating your user. So things like font, color, annotation, these are the sorts of things that differ between these two points of visualizations and how you should think about effectively communicating information. So let's think about different types of visualizations. And when I do this, I again think in spectrums. I'm going to think in two perpendicular spectrums. The first is the form spectrum that runs from static visualizations to interactive visualizations. Static visualizations, of course, are those that are not active, they're not moving. Interactive visualizations are ones in which there's a two-way exchange of information between the user and the interface. Somewhere in the middle are animated visualizations. These could be movies or films or interactive slideshows in which the user can control the pace by which he or she goes from one slide to the next. The horizontal axis is the function axis, and here we have visualizations that go from explanatory to exploratory. Explanatory visualizations are ones in which you as the creator, as the designer, are telling a story to your audience. You want them to come away with this conclusion. Exploratory visualizations are those in which you are asking your audience or your reader to go in and come away with their own stories or with their own hypotheses. And so when we put these two together, we end up with this space. And I want to walk you quickly through examples of each of these four quadrants. So let's start on the top left where most people in my field sort of live. And this is bar charts and line charts and area charts and all these sorts of things. And so we've seen the onslaught of infographics. This is one I created a few years ago for CBO. This was paired with a much larger report about federal means-tested transfer programs, EITC, Medicaid, food stamps, those sorts of programs. And you can see a title and a very short definition at the top with a quick timeline and the decomposition of 12 different transfer programs in 2012 on the left there. And that story is dominated by healthcare spending. Most of that is Medicaid. And as you pan through this graphic, paired again with the longer report, we take about 5 or 6 pages of text that tries to explain what's driving spending. Is it spending or is it participation? We take that text and put into a graphic format. Not all visualizations just have to be data. And as you pan down further, this is sort of a modular type of infographic. We show 3 different metrics: spending, participation, and average spending per participant for those 12 programs. We don't show all data for these 20 years. We just show these endpoints in this dot plot. And you can see again, you see the huge growth in Medicaid spending. You see huge increases in participation in Medicaid and in food stamps. And then as we get to the bottom of this graphic, CBO's value added, which is projections, between 2012 and 23. And again, you can see how Medicaid is projected to dominate spending on these programs over the next decade. So this is a story that we're telling to our audience. Well, what about static graphs that are exploratory? These are graphics that are not active, they're not moving, but we're asking the user to look at them and come away with their own stories, their own conclusions. This is a chord diagram from a friend of mine in Germany named Moritz Steffener. Moritz had data from a German startup company called My Muesli, where customers could order their own muesli. So he has all of these combinations. People order strawberries and grains or raspberries and chocolate. You've got the fruits here along the bottom, the grains along the left, the chocolates, I think, in the blue. It's all German, so I don't really know. And then the nuts there on the right with the green. And notice he's not telling you a specific story. You as the reader have to go in and pull out your own conclusions, pull out your own hypotheses. As another example, this is from designer Christina Schuchs, that's showing the relationship between a movie's critic score and its profitability. So for each one of these little glyphs, you have on the left axis is the Rotten Tomatoes score, and on the right axis is the profitability. So that gap shows the profitability of each movie. And again, she's not telling you a specific story, whether profitability has increased over time, or whether comedies are more highly rated than dramas more highly rated than action films. You as the user, as the reader, have to go in and pull out your own stories and your own conclusions and your own hypotheses. So now we move into the bottom half of the grid, interactives. So on the one hand, we have interactive graphics that are exploratory, and the best interactives follow a 3-step mantra set out by Ben Schneiderman about 20 years ago. Overview first, zoom and filter, details on demand. So let's take a look at an example. This is from the New York Times on President Obama's budget proposal. You have this circle packing diagram that has all these different spending categories. You get this overview of the entire budget. You can then filter by clicking any of these tabs at the top, types of spending, by category, by department. And then you can get more details on demand as you hover or roll over each one of these circles and get those specific spending numbers and growth numbers as they pop up in the boxes above. In the final quadrant, we have interactive graphs that are explanatory. Interactivity itself does not mean that you're asking your user to explore. The easiest way to think about explanatory graphs that are interactive are static charts that have some sort of technology, hover, rollover layered on top. These are just very simple line graphs from the World Bank. They've added a rollover on top. These lines go down, these lines go up. But there's this interactivity on top of it. But we can go farther than that. This is again from the New York Times. This is 512 paths to the White House. These are the combinations by which President Obama or Governor Romney could have won the White House in the last presidential election. And you as a user can choose the combinations by which each candidate could have won the election. And this is really telling you a story. You can imagine doing this in text, but they did it in an interactive visualization. So that's the space. Well, what about in the middle? Well, they're animated graphics, visualizations. It doesn't mean that they're best. It just means that they embody different parts of each of these quadrants. And let me show you 2 examples. This is from Aaron Coblin. This is called Flight Patterns. This shows flights in US airspace over a 24-hour period. And you can see as day turns to night, the country goes dark, and people start to make their trips from the West Coast over to the East Coast. And as day starts to break, you see folks from Europe come over across, and then the country starts to wake up on the East Coast. And you see, over the course of the day, flights taking off over the course of the day. And then you see folks from San Francisco and Los Angeles on the West Coast start to make their trips down to Hawaii. It embodies a lot of these different elements. It tells you a story, and it perhaps tells you a story that you would not get from a bar chart or a pie chart or just a table. It's exploratory in that you can go in and search different parts of the country, examine different patterns. It works as a static graph. It works as an interactive graph. It embodies a lot of these different elements. Let me show you one final visualization. This is from the New York Times. This is an interactive visualization on detainees at Guantanamo Base. And you have, again, elements of these 4 quadrants. You have a little play button there in the top left that moves these detainees over time. So you get this overview picture. You can then filter and zoom in by time, choosing the time period you want to look at, or you can then click on any of these squares and get more information about all of these detainees that are held at the base. So that's my view of the purpose of data visualization. And it's important for us as producers of data, as people steeped and rooted in data, to think carefully about the needs of our audience and how our visualization efforts can help them do their jobs better. So I want to close with a quick story. I'm not sure it's quick, but a story about a project that I went through thinking about the combinations, the mapping between data and graphics, and how graphics all relate to one another. How we could plot time series data as a line chart or as a column chart, or how bars relate to lines, relate to squares, relate to circles. And I call this space of graphics the graphic continuum. And so this is a pretty complex nonlinear space. This is a picture from my office a few months ago. Each one of these little post-it notes is a different graph. And we started sketching and writing, trying to come up with this space. And so this is one of our first drafts of these different graphic types, putting them all on a page and trying to figure out how do they relate to one another. And of course, this is difficult for anyone to read. So we ended up with this. This is the graphic continuum poster. I have one here that I will give away at the end. What we have here is almost 90 different graphic types, grouped into 6 categories. Distribution, time, comparing categories, geospatial, part-to-whole, and relationships. And we've pulled all these graphic types together because it's interesting to me to think about how all these graphs relate to one another and how we think about that. So what I want to do is tell you about this graphic continuum. But it's difficult to tell you a story about a complex nonlinear space in a linear narrative framework. So to do so, to tell you this story, I'm going to borrow one of my kids' books. So if you have kids, you may be familiar with these books. If you don't have kids, you should be familiar with these books because they're great. There's If You Give a Moose a Muffin, If You Give a Mouse a Cookie, If You Give a Pig a Party. And all of them use what I call a cascading storytelling device. So that in this book, the kid gives the moose a muffin, and the moose eats another muffin and another muffin until they're out of muffins. So then they want to get more muffins, so they have to go to the store to get more muffin mix, but there's a hole in their jacket. So then they have to repair the jacket, and then they decide to make sock puppets. And it just sort of cascades through this whole story. So I want to tell you the story of the graphic continuum, but I'm not going to use a moose and a muffin. I'm going to tell you the story of a nerd and a number. So, if you give a nerd a number, he might want a table to go with it, to which he can add more and more numbers, but we'll first focus on that center number, which he can plot in an XY space, to which he can add another number and more numbers. And this might remind him of other shapes he could use to present this data. For instance, a stacked area chart or a normalized area chart, or maybe a paired column chart or a stacked column chart, to which he could rotate that space 90 degrees to create a paired bar chart or a stacked bar chart. And he could go back to that line chart, add more and more data, and it might remind him that he could break this single chart apart into multiple charts, small multiples or spark lines. And this might remind him to focus just on the endpoints of that graph. And he could create a slope chart, or he could rotate that chart 90 degrees to create a dot plot. And all this uncertainty about what data we use and how we map that data to different graphic types might remind him of a fan diagram or a box and whisker plot. Or he could take those lines and put them on 2 y-axes, and this might remind him of correlations, and that might lead him to think about a scatter plot. Or he could add a third dimension to create a bubble chart, or the unfortunate 3D bubble chart. He could combine the correlations and the lines to create a parallel coordinates plot, or think about other shapes to create a radar chart. Or he might combine the time element and the scatter plot to create a connected scatter plot in which correlations are plotted over time. And the lines and the circles in this plot might lead him to think about other chart types, like a network diagram or a force-directed layout or even a hive chart. And the curves in the hive chart may lead him to think about a chord diagram. And the arcs in the chord diagram may lead him to think about an arc chart. And he could combine time in the arc chart to think about a sequential arc chart in which time is plotted from point A to point B to point C, and point A to point C. And now he's just thinking about time. And that may lead him to think about a flow chart or a tree diagram or very simply a timeline. To which again he could rotate 90 degrees to create a Gantt plot or very simply a calendar. And you can combine this concept of time and the concept of bubbles to create a nightingale, which is really just a circle that's been exploded in all different ways. And so he could rein that back in, and that might lead him to think about a pie chart, to which, unfortunately, he could rotate to create a 3D pie chart. Or he could, unfortunately, blow it up, punch a hole in the middle of it, blow it up again, cut it in half. But all of that is just a variation on a circle. This might lead him to think about other shapes, might lead him down the path of thinking about a tree map, to which he could blow up again to create a square cloud or stack it on top of each other to create a unit chart. And the squares may lead him to think about other shapes he could use to create an isotype plot. And the figures in the isotype plot may lead him to think about high-frequency data, so he might create a heat map, or a contour map, or the unfortunate 3D contour map. A lot of unfortunate around 3D, if you haven't picked up on that little theme. And the contour map may lead him to think about maps, to which he could add circles, or squares, or lines. And the connections formed by the lines on the map may lead him to think about where he's currently standing talking to you about data visualization. And he could take that single point and he can plot it in an XY space. And so if you were to give a nerd a graph, he might want a number to go with it. So that's the story of the graphic continuum, this project that we launched a couple of weeks ago, thinking about all of the relationships between graphs, between data and how we map data to those graphic types. And that when people ask me, how do I plot this data? I say, I don't know, there's lots of different ways. What does your user need? What does your audience want to see? So I want to leave you with one final thought from my friend Ben Schneiderman at University of Maryland, that when we create visualizations, our quest is not to create pretty pictures. It is to elicit insight from our audience and from our users. And so when you are working with your data, think not about trying to wow your audience with fancy animations and crazy 3Ds. Try to wow them with the depth and the clarity of your research and the depth and the clarity of your visualizations. Because if we can do a better job of communicating information, we can improve the world around us. And that, I think, is the wow that we all would like to elicit. Thank you very much. I appreciate your time.
Take some questions.
What are sort of the core tools that you use to build some of this stuff, of course excluding Socrata, that you would use to kind of build some of these visualizations? Obviously the stuff that New York Times builds is what technology they're using. Very specific, you always know that it's them when they do it. So right. In terms of, I guess, both software and also staffing, like if you were going to build this out, what kind of expertise would you hire for?
Sure. So the New York Times uses a JavaScript library called D3. They're very good at D3, not just because they're good, but also because they hired the creator of the language. So part of the answer to your question is it depends on what your audience needs, right? So again, Nancy Pelosi, I don't think, is going to be using a lot of interactive graphics. So a lot of things that I created at CBO were static. So a lot of stuff that we created was built in Excel, usually in Excel, and then piped over to a software program called Adobe Illustrator. Other tools that people are using are Tableau. Highcharts is sort of the baby step version into JavaScript. So instead of having to build a JavaScript chart from scratch, Highcharts has libraries where you could just say, build me a column chart, and here's my data, and I'm just going to bind it to that chart. And then, of course, lots of others are sort of like this explosion of tools these days, things like Plotly and Lemonly and Lyra, and they all have these fun .ly endings. But to your other question, on what do you need to build around you to do this, I view the skill sets that folks need to create effective visualizations is threefold. You need some understanding of statistics. Some understanding of statistics, math, econometrics, something where you can work with the data and be comfortable with it and use it in an appropriate way. You need some understanding or appreciation of design. So the aesthetics around what we create is important, not just for bringing users in, but also for keeping them there. And also on the analytics side, when we work with our data, understanding that that bright red line on that line chart you just created by default in Excel may appear brighter to your eye, and you may therefore subconsciously be focusing on that line without even realizing it. And then some understanding of programming so that we could build these interactive JavaScript products, for example. And what a lot of people want is they want to be the person who overlaps those three skill sets. And I call those people the unicorns because they just don't exist. People who are very good at all three of those, they're just not around. And so the goal, I think, for us as individuals is not to become the unicorn, but to build teams and organizations and firms where together we are the unicorn. So as an example, at Urban, we have about 300 or so researchers, so we're really good at the statistics, the econometric side. We've got a team of designers, about 3 designers, and we have now about 4 programmers who can build some of these custom tools. So I view it not as an individual, but as a group trying to build that skill set to create visualizations that we need.
How can we get that poster in your hand?
Ah, right, you want this poster. So there are 2 ways. I'm going to give this one out in a moment, and then you could buy it if you are so inclined. If you go to my website, policyviz.com, there is a link there. Yeah, so we can give this away now, I guess. Well, we can do questions. I'll give it away right at the end. It's sort of fun for me to play around with. Yeah.
When you're looking at the continuum that you have there,
Yeah.
And you're going back with your team and you're presented with a question, a data set.
Yeah.
What are the key milestone questions that you will ask your team to pare it down to what items in that continuum you'll explore for that particular data set?
Okay, yeah, so again, so let's assume for the moment that the team, the researcher, is well acquainted with the data, knows what's going on, sort of has sort of the lay of the land, so to speak. The next question is, again, who is the audience you're trying to communicate with? Are you trying to create a huge exploratory interactive graphic? And if so, we're going to use a lot of this data. Do you want to communicate to policymakers? If so, they just want the headline. They just want the one number that they can use to communicate with their staff or their constituents or their colleagues. And if that's the case, then we're in sort of a different world. But the sort of process answer, which I get a lot, how do you create these visualizations? And I always tell people, I don't really know, I just sort of do it. But the real answer is, I don't start by opening the computer and working and sort of, trying all these different forms out. Assuming I'm familiar with the data or the model or whatever it is, the first thing I do is start sketching. I didn't show you all the stack of drawings that I have on this project, but I have sheaths of paper just trying all different combinations. So my process is always starting in the analog world and then moving into the digital world. And you create a dozen different prototypes on paper, and then half of those aren't going to work, and then the other half aren't going to look very good, and then you start over again. So I'm not sure that totally answers your question, but that's sort of my process.
More questions?
Yeah, so my website is policyviz, Policy, viz.com. And there's a link on there it's being sold through Mimeo, which is my publisher. Okay. Okay, so let's, should we just give this away? Everybody's like, ooh, I want the poster. Free poster.
Some kind of like talent contest.
Yeah, right. Yeah, right. Okay, so I need a volunteer.
Oh, it is gonna be a bit of
Okay, you win.
Awesome.
All right, thank you very much.